Hello, Namaste, Konnichiwa, welcome to Sunny Sensei. In this lesson, we'll explore something very interesting, the zeros of a polynomial. A zero is simply a value of x for which the value of the polynomial p of x becomes 0. Let us take a simple example. Consider the polynomial 2x minus 4. Let me first write this in the standard form. 2x to the power 1 minus 4x to the power 0. The highest power of x is 1. So, this is a polynomial of degree 1, a linear polynomial. Now let us find the zeros of this polynomial. We have to find the value of x for which p of x equals 0. So we get 2x minus 4 equals 0 or 2x equals 4. And finally, x equals 2. So, x equals 2 is the zero of this polynomial. At this value, the polynomial becomes 0. And since this happens for only one value of x, this polynomial has 1 0. Now we will look at how the value of this polynomial changes with x. Here is a table with the value of x in the first column. And in the second column, we have the corresponding value of the polynomial. Y equals p of x. When x is minus 2, p of x becomes 2 into minus 2 minus 4, which is minus 8. When x is minus 1, the value is minus 6. When x is 0, the value is minus 4. When x is 1, the value is minus 2. And when x is 2, we have 2 into 2 minus 4 or 0. The value of the polynomial is 0. We have a 0 at x equals 2. Now let's plot these values on a graph. On the x-axis, we have the variable x. And on the y-axis, we have the value of the polynomial, p of x. When x is minus 2, px is minus 8. The other points are minus 1, minus 6, 0, minus 4, 1, minus 2, and 2, 0. Now if we join all these points, we get a straight line. Look at this point carefully. Here, the value of x is 2, and the value of the polynomial is 0. So, x equal to is a 0 of this polynomial. Notice that this is the point where the graph intersects the x-axis. Remember, the zeros of a polynomial are the x values where the graph intersects the x-axis. In this example, the graph intersects the x-axis only once. So this polynomial has exactly 1 0. This is a linear polynomial with degree equal to 1. And all linear polynomials have two important features. First, their graph is always a straight line. Second, they always have exactly 1 0, one point where the graph meets the x-axis. So, the number of zeros of a linear polynomial is always 1. Let's take one more example. X square minus 4. We can write this in the standard form as 1x to the power 2 minus 4x to the power 0. The highest power of x is 2. So we have a polynomial of degree 2, a quadratic polynomial. Now to find the zeros, we set p of x equal to 0. So we have x square minus 4 equals 0. We can write this as x square minus 2 square equals 0. Now, a square minus b square equals a plus b, a minus b. So we have x plus 2, x minus 2 equals 0. And this gives us x equals minus 2 or plus 2. This polynomial has zeros at x equals minus 2 and plus 2. There are two values of x for which the polynomial equals 0. Now going to our table. When x is minus 4, px is 12. When x is minus 2, px is 0. The other points are the polynomial becomes 0 at x equals minus 2 and at x equals plus 2. These are the two zeros of this polynomial. Now let's plot the graph. We have the xy plane, and here are our points. If we join them, we get this curve. This is a parabola. And notice, the graph intersects the x-axis at 2 points. At x equals minus 2 and at x equals plus 2, the zeros of this polynomial. So once again, zeros of a polynomial are the points where the graph meets the x-axis. Now let's look at a few different situations. We already have the graph for x square minus 4. Here are two more polynomials. X square in the standard form is 1x square. X square plus 4 is 1x square plus 4x to the power 0. Both are quadratic polynomials of degree 2. This is how the graph of x square looks like. The graph just touches the x-axis at this point. We have a 0 at x equals 0. This polynomial has only one 0. Next, we have the graph for x square plus 4. The graph never intersects the x-axis. The value of the polynomial never becomes 0. So this polynomial has no zeros. The number of zeros is 0. Now let's move ahead and look at one more example. We have 4, which we can also write as 4x to the power 0. The highest power of x is 0. So this is a polynomial of degree 0, a constant polynomial. Now let's find the zeros. We set p of x equal to 0, and we get 4 equals 0. This is not possible. This means there is no value of x for which the polynomial becomes 0. This polynomial has no zeros. The number of zeros is 0. Now let's plot the graph. The graph is a horizontal line parallel to the x-axis. It never touches the x-axis. So this polynomial has no zeros. Moving ahead, let's now look at a special case. Consider the polynomial p of x equals 0. We can write this as 0x to the power 0 or 0x to the power 1 or 0x to the power 2 and so on. Since the coefficient is 0, the power of x doesn't matter. It can be anything. So there is no highest power of x, and the degree is not defined. The type by degree is also not defined. Now let's find the zeros. We set px equal to 0, and we get 0 equals 0. This is true for every value of x. So this polynomial becomes 0 for all values of x. X belongs to R. That means x can be any real number. The number of zeros is infinite. Now let's look at the graph. We have the xy plane, and here is the graph for px equals 0. It lies completely on the x-axis. Every point of the graph is on the x-axis. So we have infinite number of zeros, or zeros for all values of x. Let me now clear the screen and list all the polynomials we have discussed so far. Here are some important observations. For a constant polynomial, such as px equals 4, we have no zeros. This is true only for a non-zero constant polynomial. For the special case, where px equals 0, the polynomial becomes 0 for every value of x. So, the number of zeros is infinite. For a linear polynomial, we always have exactly one zero. For a quadratic polynomial, we can have two zeros, 1 0, or no zeros. A quadratic polynomial can have a maximum of 2 zeros. In general, a polynomial of degree n can have at most n zeros. For example, a polynomial of degree 5 can have a maximum of 5 zeros. Zeros are not just numbers. These are the points where the graph of a polynomial meets the x-axis. With this, we are done with our discussion on zeros of a polynomial. In the next lesson, we'll explore the relationship between the zeros and the coefficients of a polynomial. If you found this lesson useful, don't forget to like, share and subscribe to Sensei. Thank you and see you again in the next lesson.